Okay, so this is section 6-4. This is video number 3. All right, so what he's saying here, the closeness of the normal approximation is shown in this next example. What he means by that is how good of an approximation is it? What is it? Is it good, bad, indifferent? What can we say about that? So what we're going to do here is we're going to calculate it in two different ways. We're going to use the binomial distribution to calculate it, and that's the first way, and then the second way is we're going to use the normal approximation, and we're going to see how good of a job did it do. That's the concept here. All right, so here's the example 6-19, the binomial versus the normal approximation. So binomial is the exact answer. Normal distribution is the approximate answer. So he says n is equal to 10, p is 0.5. We're going to use the binomial distribution table, which I'm not 100% sure we've talked about before, but we'll do it now, to find the probability that x is equal to 6. So the number of successes is 6. Then use the normal approximation to find the probability that x is equal to 6. So how good of a job does the approximation do? Okay, so n is 10, p is 0.5, x is 6, the probability is 0.205. That's from table B. Well, how did that happen, right? Okay, so let's take a look. Give me one quick second here. All right, so this is the PDF version of the text, edition number 9. As you can see in the back, we've got these various tables. Okay, table A is factorials, table B binomial distribution. We've been using this one quite a bit, E, the normal distribution. Okay, so let's take a look at what we want is B, binomial distribution. Okay, so here it is. So the way this works is you have P across the top, N is down here, and then X, the number of successes, is here. So all you have to do is find the appropriate place to give you the appropriate row, and then you find the appropriate column by finding the appropriate, or the given probability of success, the given P. So let's see if we can figure that out. Okay, so N is 10, P is 0.5. That's what we're told right there. So let's take a look at the table. So N is 10, N is 10, okay, and we want an x of 6. That's the number of successes is 6. So, like whatever it happens to be, whatever the experiment happens to be, 6 successes. Here's the 6 successes out of the 10 trials. So 6 successes. So this right here. This is the row that I want. The P is given to us as being 0.5. So 0.5, go across here, 0.5 is right there, 0.205. 0.205 is the probability of getting 6 successes out of 10 trials if the probability is 0.5. Right there, 0.205. So let me close this, and boom, that's exactly what the author said. Okay, so you may say to me, well, why do I even need to fool around with this normal approximation if I've got these tables? Well, the tables can't go forever. I mean, if you had an n of 200, do you think there's a table for that? Of course not. So you have to, you have to have different techniques depending upon the situation that we're in. All right, so now we're going to do the normal approximation. Just as before, mu is np, sigma is square root npq. Multiply these out, and you get a mu of 5. And I just noticed, well, first of all, you get a mu and you get a sigma, so we have what we need here. But what I just noticed was that the author didn't take that step of making sure that the approximation was appropriate or not. You remember, it has to be n times p has to be greater than or equal to 5, and n times q has to be greater than or equal to 5. Well, it's easy enough. We'll just do it. 10 times 0.5 is 5. That's what P is. P is 0.5. Q is also 0.5. So N times Q is also 5. So the approximation is legitimate. Okay. Okay, so again, doggone it, you better write out these formulas when you do work for me. Write out the darn formula. It's x take away mu over sigma. Okay, so just plugging that in here. 6.5 take away 5. That's the guy right here. 5.5 is the other guy. Okay, the boundaries here that correspond to x equals 6. You go from 5.5 to 6.5. So you find the area to the left of 6.5, find the area to the left of 5.5. You subtract those two areas, and what's left over is, boom, right there. And what does that give us? The area between the two z values are 0.2034. Okay, now, 0.2034, he says, is very close to the binomial table value of 0.205. Okay, so that's kind of a judgment call. You'd have to decide ahead of time how close you want it to be, but it's pretty darn close. Okay, so that's the concept. Something else he talks about here is how the normal approximation, the normal distribution is also used to approximate other distributions, such as the Poisson distribution. Okay, so that's the end of this section. That's the end of this chapter. So what we did here in chapter 6 is we talked about the normal distribution. So it's a very important distribution. We discussed it at length. Talked about a few applications. Please take my advice, and I know you can't do all of the exercises, and I don't even assign them because I know it's just too many. Okay, but if you, as much time as you can, at least take a quick look at the exercises, because what the exercises will do is give you examples, and you'll find an example that you think is cool, that you like, and that you think is interesting. Okay, and everybody's going to have their own interests, obviously. Okay, so what you have to do is you have to figure out, you have to find ones that you think are of interest to you. Okay, all right, so that takes care of chapter 6.